All right, so in this video, we're going to go over the answers to the first homework. So I'll just talk through them kind of in order. So for number 1, we are negating a statement, being sure to change the quantifier and write in full sentences using proper grammar. So the first statement is there exists a prime number that is even. So if we want to say it's not true that there exists a prime number that is even, this is an existential quantifier. We need to change it to a universal quantifier. So that would be all prime numbers do not have the property that's given, which is even. So we would say all prime numbers are not even, or all prime numbers are odd. And then for the second one, B, we have the universal quantifier all, so we change that to an existential one, which would be there exists or there is. So if it's not true that all natural numbers are odd, then the negation of that would be there exists a natural number that is even, or not odd, that is even. Or I suppose you could say there exists an even natural number if you wanted to be a little bit more concise about it. All right, so then moving on to question 2. A and B are sets where A is the set containing A, B, C, D, and E. B is the set containing B, C, and D. And the question says to list all sets C for which C is a subset of A and B is a proper subset of C. So we're kind of looking for, I don't want to use the word inequality, but we can kind of think of sets and subsets as kind of being inequalities. So we're looking for the set C that kind of satisfy this relation here, which is, so these are the sets C that we're looking for contain B as a proper subset, but are also themselves subsets of A. Okay, so what does that mean? If C has to contain B as a proper subset, that means C has to have the elements of B in it, which are B, C, and D. Okay, but if it only had B, C, and D, then it wouldn't contain B as a proper subset. So C has to have kind of some extra elements. So it could have the element E in it. So just take a minute to make sure you believe that this set that I just wrote down fits this relation over here. It's a subset of A because it only contains the elements that are in some of the elements that are in set A, and it contains B as a proper subset. Kind of thinking along those same lines, we could also include the element A. So C could be the set A, B, C, and D. Again, notice that B is a proper subset of that, and that set itself is a subset of A. And the other set that C could be is actually the set A itself, because that contains B as a proper subset, and it is a subset of the set A because it's equal to the set A. So those are, the hint that I gave you was that there are 3 sets. There's 1, 2, 3. All right. Question 3, you're allowed to make up your own sets here, but they have to satisfy these properties. The cardinality of A is 3, the cardinality of B is 5, and the cardinality of A union B is 6. So remember, the union is basically taking the elements in set A and the elements in set B and putting them together. So for instance, we could take A to be the set, let's kind of make things easy, just say 1, 2, 3. Then the cardinality of A is definitely 3. All right, the cardinality of B has to be 5, but we want the union of these two sets to be cardinality 6. Okay, so what does that mean? We already know that these 3 elements, 1, 2, and 3, are going to be in the union of A and B. So basically we would need kind of 3 new elements. So to add to that, so A and B of course are going to have some overlap. So if we make set B 2, 3, 4, 5, and 6, then notice that that has cardinality 5 because there are 5 elements there. And then the set A union B would be 1, 2, 3, 4, 5, 6, which of course has cardinality equal to 6. All right. Now, of course, that's not the only answer, but that's one answer that does work. All right. So we're doing something kind of similar for question 4. This time the cardinality of A and B are both equal to 4, and the cardinality of their intersection is 2, which in other words means that they have 2 elements in common. So maybe I'll do something a little bit different here. I'll use letters instead of numbers. So if A has to have 4 elements, we could say A, B, C, and D. We know that B has to overlap 2 of those elements, so I'm just going to choose C and D. That's a funny looking E. And then maybe C, D, E, F. So notice they both have 4 elements. They both have cardinality 4. And then A intersect B would be the element, the set containing C and D, so that the cardinality of A intersect B is equal to 2. Moving on to number 5, true or false. Kind of the trick here, or the thing that I want you to be aware of or be careful about, is that this notation right here means the set containing the empty set. So the question is the set containing the empty set an element of the power set of A, where A is the set containing the elements 0 and 1? So maybe it would be helpful in one way to write out the power set. What is the power set of A? The power set of A is the set of all subsets of A. And we know that the empty set is always there. We could choose just the element 0, we could choose just the element 1 to make subsets, or we could choose the whole set A itself, which is 0 and 1. All right, so what do we have here? These are the elements, right, of the power set of A, and we can see that it's true that the empty set is an element of the power set of A, but if we put squiggly braces around this, that makes it false, because that's saying the set containing the empty set is one of the elements listed in the power set of A, which is not true. Okay, so, whoops. To be clear, the empty set is an element of the power set of A is true, but the set containing the empty set is not an element of the power set of A. All right. So I guess I just wanted to draw attention to the fact that this is the empty set. This is a set with one element in it, that element being the empty set. Okay. Question 6, list all subsets of K, which is the set Wx of elements W, X, Y, and Z that have cardinality 2. So basically we're just choosing 2 elements from this set and putting them together as a subset. So we could choose Wx, Wy, Wz. We could choose Xy or Xz or even Yz. All right. And I do want to point out that so right here I have the set Wx listed. That's actually the same as the set containing Xw, right? This one and this one are actually the same set. It doesn't matter the order that we write them in. So we don't want to include this one over here. All right. So there are just 6 of those subsets that have cardinality 2. Whoops. All right. And our last one, we're writing a proof. Consider the implication. If A is odd and B is even, then the product A times B is even, and we want to prove it. Okay, so remember, for proof of an implication, we get to assume the hypothesis, and we want to show that the conclusion is also true. Okay, so let's just jump into it. Assume A is odd and B is even. All right, so basically the only place that we can go from here is, what do we know if A is odd and B is even? Well, if A is odd, then there exists an integer, let's call it J, such that A is equal to 2J plus 1, because remember that's what we said it means to be an odd number, and there exists also an integer I guess we'll call this one K. Such that B is equal to 2K, because that's what it means to be even. It means to be 2 times an integer. Okay. So what do we do from here? Well, we're trying to say something about the product, A times B. So we could simply multiply those together. Remember that when you're doing this, you still want to write in full sentences. So you could say we have. So kind of writing it in full sentences as simple as kind of starting your sentence with some words rather than just jumping into the calculations. Whoops. And I'm just going to write it down here so I have more space. A times B. So A is equal to 2J plus 1. B is equal to 2K. So what we want to do from here is kind of multiply this out or distribute it. So 2J times 2K would be 4JK. And then 1 times 2K would be 2K. And remember, we're trying to show that this is even, right? That's kind of our goal of this proof. So an even number is something that is 2 multiplied by an integer. So if we factor out a 2 from what we just wrote here, we would be left with exactly, whoopsies, 2jk plus k. And I know that there's also a common factor of k here, but I'm not really worried about factoring that out because all we want to do right now is show that this is even. Okay, so now we could say because 2jk plus k is an integer, and 2 times an integer is even. We have the product. We have that the product A times B is even. All right, so remember what we did here. We clearly stated our assumptions, and then we kind of went from there using our definitions of odd and even. We multiplied them together, again, pulling out a 2 to make sure that we show that AB is even, and then we just kind of write a final sentence to conclude.